So, importance of coordination compounds. Coordination compounds are widely present in hi, hello. The coordination compounds are present in the minerals, the plants, and the animals. যে সমস্ত বিষয়ে কোঅর্ডিনেশন কম্পাউন্ডসগুলি গুরুত্বপূর্ণ ভূমিকা পালন করে সেগুলো হচ্ছে the coordination compounds play the important role in the area of analytical chemistry, metallurgy, biological system, industry, and medicine. Industry and the medicine. Please like and subscribe my channel. I need your support, guys. Coordination compounds play important role in the area of analytical chemistry, the metallurgy, the biological system, the industry, and the medicine. Coordination compounds find use in many qualitative and quantitative chemical analysis. Coordination compounds find use in many. Please like and subscribe my channel. qualitative and quantitative chemical analysis. So the importance of coordination compounds are, first one is the coordination compounds are widely present in the minerals and the plants and animals. Coordination compounds play important role in the area of analytical chemistry, the metallurgy, the biological system, the industry and the medicine. Coordination compounds find uses in many qualitative and quantitative chemical analysis. Now we'll read about the color reaction, and let me read NCERT words they are written. Coordination compounds are of great importance. These compounds are widely present in minerals, plants, animals world and are largely known to play important functions in the area of analytical chemistry, metallurgy, biological system, industry and medicine, and these are described below. Coordination compounds find use in many qualitative and quantitative chemical analysis. Yes, I have beautiful notes and I break down these NCERT lines and written beautifully in my copy. Coordination compounds are widely present in minerals, plants and animals. Coordination compounds play an important role in the area of analytical chemistry, metallurgy, biological system, industry and medicine. Coordination compounds find use in many qualitative and quantitative chemical analysis. Now let's study about the color reaction. See, this is my beautiful notes. Okay. My teacher has written it beautifully. He is an excellent teacher. Color reaction. Color reaction. What is written in the color reaction? The familiar color reactions given by metal ions with a number of ligands, especially chelating ligands, as a result of formations of coordination entities, form the basis for the detections and estimations by classical and instrumental method. Example of such reagent includes EDTA, DMG, dimethyl glycozyme, alpha nitroso, alpha naphthalines and kypron, etc. If you want this kind of notes, you can contact with my teacher. So color reaction. So when chelating ligands and metal ions react, it will form the coordination entities, and coordination entities means the coordination compounds. It forms the basic for their detections and estimations of ions, and ions are of two types. One is cation and second one is anion. By chemical and industrial method of analysis. And examples of such reagent includes EDTA, DMG, dimethyl glyoxime, and it contains nickel, and alpha nitroso, beta naphthalene and kypron. Alpha nitroso and beta naphthol. Alpha nitroso and beta NAPH. I've written wrong. NAPH naphthol THO. So please like and subscribe my channel. It formed the basic for their detections and estimations of ions by chemical and industrial method by analysis. Example EDTA, DMG, dimethyl glyoxime, alpha nitroso, alpha naphthalines and kypron. These are the examples. So 4 points I have read. First one is the chemical coordination compounds are widely present in minerals, the plants and animals world. Chemical coordination compounds play an important role in the area of analytical chemistry, the metallurgy, biological system, industry and medicine. I will block Anil what he is telling. behave properly. So color retention. First one is the chelating ligand. How color retentions form? Chelating ligands plus metal ions form the coordination entity, and coordination entity means the coordination compounds. It forms the basic for the detection and estimations of ions by chemical and industrial method of analysis. Example EDTA DMG, that is dimethyl glyoxine, and it contains nickel. And the third one is the alpha nitroso amsa naphthols, and the one is the cupron. So this is my rough copy I am writing here. Coordination compounds are widely present in minerals, plants and animals. Coordination compounds play an important role in the area of analytical chemistry, metallurgy, biological system, industry and medicine. Obviously medicine, industry, biological system, metallurgy and an area of analysis. Coordination compounds find uses in many qualitative and quantitative chemical analysis. This one is very important about the color reaction. Color reaction, that is chelating ligand plus metal ions form the coordination entity. It forms the basic for the detections and estimations of ion. It forms the basic for their detection. It forms the basic for the detection and estimation of ion. Example EDTA DMG dimethyloxane, and it contains nickel, alpha nitroso and beta naphthol, and third one is the cupron, CuPRON, cupron. Coordination compounds find uses in both qualitative and quantitative chemical analysis. It plays an important role in area of analytical analysis and area of analytical chemistry, metallurgy, biological system, medicine and industry. Chemical coordinations are widely found in plants, animals and minerals. Color reaction, chelating reagent plus metal ions form the coordination entities. It forms the basic for the detection and detections and estimation of the chemical and industrial method of analysis. Of the chemical and industrial method of analysis. Example EDTA DMG dimethyl glyoxine, alpha nitroso and alpha naphthol, and third one is the cupron. So let me drink water, and please subscribe and like, give one like and please subscribe my channel. Hardness of water estimated by simple titrations with Na2 EDTA, Ca2 plus and Mg2 plus, and Ca2 plus and Mg2 plus, they are group 2 elements, and it forms the stable complex with EDTA. So Ca2 plus and Mg2 plus, these are ions, and plus EDTA, it forms the stable complex. The selective estimations of ion can be charged due to difference in the stability constant of calcium and magnesium complex. Please like and subscribe my channel. Subscribe my channel and like this live actually. It's my slip of tongue. So hardness of water can be estimated by simple titration and simple titration with Na2 EDTA. And calcium Ca2 plus and Mg2 plus, and these are group 2 elements. So it forms stable complex with EDTA. Yes. So selective estimations of ions can be charged due to difference in the stability constant of calcium and magnesium complex. Let me do it in CRT what's written. Hardness of water is estimated by titrations with Na2 EDTA. The calcium ion and magnesium ion form the stable complex with EDTA. The selective estimations of these ions can be done due to difference in the stability constant of calcium and magnesium complex. Some important extraction process of minerals like those of silver, gold make use of complex formation. Gold, for example, combines with cyanide in the presence of oxygen and water to form coordination entity AuCN2- in aqueous solution. Gold can be separated in metal form from this solution by addition of zinc. In NCERT, everything is lined. There is no point where I see how it's written in NCERT. Can you see the point? But in my tuition, my teacher has written very beautifully. His notes is awesome. He makes us understand what is there, what is important, and give us the concept. So it will be very much beneficial for us. Some important extraction process. Metals are the metals are silver and gold. Make use complex formation. Silver and gold extraction form the complex coordination complex, means the coordination complex, or সিম্পল কম্পাউন্ড গঠনের মাধ্যমে যে সব মেটালের এক্সট্রাকশন করা হয় সেটা হলো গোল্ড অ্যান্ড সিলভার। গঠনের মাধ্যমে যেসব মেটালগুলোকে এক্সট্রাকশন করা হয়। সাম ইম্পর্টেন্ট এক্সট্রাকশন process metals are silver and gold and make use complex formation. Gold and cyanide react with oxygen and water, and this oxygen and water, these are the aqueous solution, means when oxygen react with water, so water is present, obviously it will be an aqueous solution. So the aqueous solution will result in AuCN2-. Gold can be separated in metal form from this solution by addition of zinc. So this solution can be separated with the help of zinc. এই দ্রবণে জিঙ্ক যোগ করে গোল্ডকে ধাতু রূপে আলাদা করা হয়, obviously. Purification of metal achieved through formation and subsequent decompositions of coordination compounds, and impure nickel is converted to NiCO4, which is decomposed to yield pure nickel, and so it means impure nickel is converted to NiCO4 and it get decomposed, then we will get pure nickel. How we get pure nickel? After decomposition, and when the impure nickel converted to NiCO4, and NiCO4 structure is tetrahedral and its hybridization is sp3. So when it get decomposed, it will form the pure nickel. So in the morning, up to this, my teacher taught me. He is doing very hard work. So hardness of water can be estimated by simple titration with Na2-EDTA. Yes. Calcium and magnesium, these are group 2 elements, and it forms the stable complex with EDTA, stable complex with EDTA. So CO2 plus and Mg2 plus, these are group 2 element and it forms stable complex with EDTA. The selective estimations of these ions can be charged due to difference in the stability constant of calcium and magnesium complex. Selective estimations of this ion, selective estimation of this ion can be charged. Selective estimations of ion can be charged due to difference in the stability constant of calcium and magnesium complex. So selective estimations of ion can be charged due to difference in the stability constant of calcium and magnesium complex. Difference in the stability constant of calcium and magnesium complex. Difference in the stability complex of difference in the stability constant of calcium and magnesium complex. Some important extraction process of metals, and these metals are gold and silver. Gold and silver extraction from the complex, and that is the coordination complex. Coordination complex from the coordination complex গঠনের মাধ্যমে সব এলিমেন্ট যেসব এলিমেন্ট এক্সট্রাকশন করা হয়. So when coordination complex are formed, the metals are extracted are gold and silver, and gold plus cyanide. When gold react with cyanide with water and oxygen, so when water and oxygen react, that means it forms an aqueous solution, and that is AU, and it forms AuCN2 minus, and this gold can be separated in metal form from this solution by addition of zinc. Gold can be separated in metallic form from this solution by addition of zinc. So when AuCN2 minus plus Zn form, then gold can be separated. So when AuCN2 minus plus Zn form, and when zinc is given, then gold will be separated. Purification of metal can be achieved through formation and subsequent decompositions of carbonation compounds. So impure nickel actually converted to the nickel CO4, and it get decomposed and it converted into pure nickel. Importance of coordination compounds. Coordination compounds are widely present in, what the hell? So importance of coordination compounds. Coordination compounds are widely present in minerals, plants and animals. So the importance of coordination compounds are found in the area of analytical analysis, metallurgy, biological world, biological system, industry and medicine. Coordination compounds are found in qualitative and quantitative chemical analysis. Coordination compounds are found in qualitative and quantitative analysis. Color detection. So chelating ligands and metal ions form the coordination entity. It forms the basic for detections and estimations of ions by chemical and industrial method of analysis. And for example, EDTA. It forms the basic for detections and estimations of ions by chemicals and industrial method of analysis. An example, EDTA, the Ng dimethyl glyoxime, and it contains nickel. Please like and subscribe my channel. And alpha nitroso, alpha naphthalene, sorry naphthol, alpha nitroso, alpha naphthose and ketone, alpha nitroso. Please like and subscribe my channel. Gold can be separated in metallic form from these solutions by addition of zinc. Yes, purifications of metal active to formations and subsequent equations of their coordination compounds. Impure nickel is converted into NiCO and it get decomposes and it forms pure nickel. So I have revised my chemistry. Bonding in carbonyl compounds. So to find the bonding in carbonyl compounds, so we need metals and carbonyl compound, and metal should be the transition metal. Now for metal, there should be one orbital vacant, means there should be one vacant orbitals and 4 filled orbitals. So 4 full filled orbitals and 1 vacant orbital, so the total orbital will be 5. And d orbital shape is d dumbbell shape or double dumbbell shape. And for the carbonyl compounds, only there will be one lone pair, and one lone pair contains 2 electrons, and these 2 electrons form one bond, and it forms the pi star antibonding orbital. Pi star antibonding electron increases. So when the transfer of electrons occur from fulfilled d orbitals of metals to carbonyl compounds orbitals, and that is not vacant orbital, that is the vacant pi star antibonding orbital. So there is transfer of electrons to antibonding orbitals. That's why there will be increase in electrons in that. Therefore, there will be bond order decreases, as bond order formula is Nb minus Na by 2, and it will be 2 minus 5. I'm taking the example, when suppose consider 2 minus 5 by something 2, and the answer will come in negative, so the bond order is decreasing. So metal carbon sigma bond. Metal carbon sigma bond is formed by the donation of one lone pair of electrons or carbonyl compounds into vacant orbitals. So metal carbon sigma bond is formed by donation of lone pair of electron from the carbonyl compounds into the vacant orbitals of the metal. So from the carbonyl compounds, the lone pair is donated to the metal vacant orbitals. So that's why metal carbon sigma bond formed, and there will be head-on overlapping. Due to head-on overlapping, there will be sigma bond. Metal carbon pi bond. The metal carbon pi bond is formed by the donation of lone pair from the full-filled d orbitals of metal into the vacant antibonding orbitals, and there will be pi star orbitals of carbon monoxide. And so there is sidewise overlapping and back bond, back donation pi bond. There will be sidewise overlapping and back donation pi bond. There will be sidewise overlapping and back donation pi bond. There will be sidewise overlapping and back donation pi bond. There will be sidewise overlapping and back donation. There will be sidewise overlapping. There will be sidewise overlapping and back donation pi bond. So it will lead to the pi bond. Sigma bond is formed when the lone pair is donated from the carbonyl compounds to the vacant orbitals of the metal. There is head-on overlapping. That's why there will be metal carbon sigma bond, and metal carbon pi bond is formed when the lone pair is donated from the full-filled orbitals to the vacant pi star antibonding orbitals of the carbonyl compounds, and there is sidewise overlapping and back donation pi bond. So this will lead to the pi bond, and the effects will result in synergist effect. CO is also known as the carbon monoxide. It is also termed as the carbonyl compound. It is a strong field ligand. Metals to ligand bond creates synergic effect. Metals to ligand bonding creates a synergic effect. Metals to ligand bond creates a synergic effect, and metals to ligand bond creates a synergic effect, and it strengthens the bond between the carbon and metal. It strengthens the bond between carbon and the metals, and metals are known as acid pi ligand. It is known as acid pi ligand, so because it formed where the vacant antibonding pi star orbital formed where the vacant antibonding pi antibonding, not pi star, I am just it's my mistake, that antibonding orbital formed. Acid pi ligand formed where the vacant antibonding pi orbitals formed. Are you reading NCERT? Yeah, after reading my teacher's note, I read NCERT, and that's my similar mistake that I've done yesterday. I said 5 star is where anti-bonding orbitals are found. So carbonyl compounds, these are strong field ligand. It is known as carbon monoxide. Acid pi ligand is formed where the back end anti-bonding orbitals are found. Applications of synergic effect is due to the synergic bondings and charge density. So due to synergic bonding, metal carbon bond, when the bond energy increases, bond order increases and bond length decreases. I have to read teacher's note because I want to clear my concept, and after reading my teacher's note I am reading NCERT. My teacher is giving NCERT notes only, but written in NCERT he is just clarifying that. Don't read teachers. I need teacher to make the concept clear. Due to synergic bonding, metal carbon bond energy increases, bond order is also increases and bond length decreases, and carbonyl compounds bond energy decreases, bond order is decreases, and bond length increases. There is a less difference in the bond length of in the synergic bonding. If carbonyl bond length in CO is 1.128 Armstrong, then what is the value of CO bond in FeCO5? That is 1.15 Armstrong. Compare the CO bond strength MnCO6 after finding the oxidation number, and we have already read about the charge density of metal carbon bond and carbon oxygen bond. Metal carbon positive greater than neutral greater than negative greater than neutral and then NCERT help you involve in subject. If you are earlier reader note, then you won't be able to involve in subject. Improve the subject, create long term memory, no need of revision. NCERT helps you involve in subject. If you earlier read notes, then you won't be able to involve in subject. Involve subject, create long term memory, no need of revision. Bond charge density is negative, then oxygen, then positive. But in Neet, conceptual question will come, so I have to build concept also, right? And he's giving NCERT notes only. Means he's extracting everything from NCERT. Thanks for the suggestion. There is no concept for long-term memory. It is wasting your time and so many reading less memories. Less memories. What are you saying? Neet, I have got many questions and from his note and from NCERT also. He's making the concept clear actually. He's making my concept clear because when I read NCERT, in his NCERT, everything is written line by line. So if I don't read his notes and before I read NCERT, I am not able to understand. Means few things I can't understand. So that's why I'm focusing his notes, and his note is NCERT based only. No line he has missed. So what can be done for long-term memory? I'm writing also in my copy. What can be done for? I'm not wasting time, bro. Are you a NEET aspirant or you have cracked NEET? It's your own choice. If you don't revise, then it will not go into your long-term memory. Wow, nice. So why are you here then? I believe that if I revise multiple times, then only I can get that into my long-term memory. So what is organometallic compounds? Organo means organic and it comes from carbon. So metal here is the transition metals, the compounds in which metal is directly bonded with the carbon. That is the organometallic compounds. You are wasting my time. Leave that. Organometallic compounds. Organo means organic and organic, and from organic it comes to our mind that organic deals with carbon, and here the metal will be the transition metals, the compounds in which metal is directly bonded with the carbon. That is the organometallic compounds. Organometallic compounds are of two types. First one is the ionic organometallic compounds and second one is the covalent organometallic compounds. Ionic organometallic compounds, for ionic means ions, which means anions and cations, and ionic compounds are present between the metals and carbon, and R minus Li plus, then R is the methyl group, that is the CH3 group. Covalent organometallic compounds. Covalent means sharing of electron. Covalent bonds are present between the metal and the carbon. Covalent bonds are of three types: sigma, pi and sigma pi bond. Sigma bond means there should be single bond, and single bond has two electrons, and when there is two unpaired electrons there will be one single bond. Sigma bond present between the metal and the carbon. Example, tetramethyltene, and its structure is tetrahedral. Tetramethyltene, and its structure is tetrahedral. Yes, tetramethyltene structure is tetrahedral, and tin is a metal. RMGX is the Grignard reagent, and it is the organic metal. So number of sigma bond in RMGX is 5 sigma. There is 5 sigma bond, and there is 1 2 3 4 5 carbon. 1 2 3 4. Please like and subscribe my channel. So pi bond is donated by double bond. When there is one double bond, there is one sigma bond and one pi bond. When there is three double bond, there is one sigma bond and two pi bond. And when there is one bond, there is one sigma bond and zero pi bond. For ferrocene, Fe n to the power 5 C5H2 twice 2. Number of the denticity will be 5. For ferrocene, denticity will be 5, and N denotes the number of carbon ring and the long chain. Dibenzene chromium. Dibenzene chromium. Dibenzene means there is two benzene and its hapticity will be 6. Dichromium, dibenzene chromium into the power 6 C6H6 whole twice 2, and its hapticity will be 6, and for ferrocene hapticity will be 5, and for this salt and that is potassium PtCl3 into the 2 C2H4 its hapticity will be 2. So for this salt, its formula will be K potassium K PtCl3 into the 2 2H4 and its hapticity will be 2, and for dibenzene chromium Cr into the 6 C6H into the 6 C6H6 whole twice 2 and its hapticity will be 6, and for ferrocene Fe into the 5 C5H2 whole twice 2 and its hapticity will be 5. For sigma and pi bond, it occurs between metals and carbonyl compounds. And for example, NiCO4 its hybridization is sp3 and it's tetrahedral. For MnCO5, its hybridization is dsp3 and it's trigonal bipyramidal. FeCO5 its hybridization is dsp3 and its shape will be trigonal bipyramidal. CrCO6 is hybridization will be d2sp3 and its shape will be the octahedral, though ligand is 6 there, that's why its shape will be octahedral. And for Mn2CO10 its shape will be there will be two trigonal bipyramidal, and CO2CO8 there will be two trigonal CO2CO8, so its shape will be two tetrahedral unit. CO4 its structure will be two tetrahedral unit. Its structure will be two tetrahedral unit. Limitations of crystal field theory. Crystal field models successfully explain which property of coordination the compound. So the properties are the formation, the structure, the color and the magnetic property. Crystal field in crystal field model, ligand is used and ligand is considered as a point charge. As a result, anionic ligands iodine, fluorine, chlorine should exert the greatest splitting effect. As a result, anionic compounds iodine, fluorine, chlorine should exert greatest splitting effect. In crystal field model, ligand is considered as a point charge, and as a result, anionic ligands fluorine, chlorine, iodine should exert the greatest splitting agent. What is anionic ligand? The anionic ligand actually are found at the lowest end, and the lowest end means the left side of the spectrochemical series. Anionic ligand does not take into account the covalent character of bonding between metals and ligand. Anionic ligand does not take into account the covalent characters of bonding, and covalent bond means the sharing of electrons and metals, and here sharing of electrons occur between the metals and the ligand, and there is sharing of electron. The sharing of electrons occur when there is unpaired electrons and there should be single electron. Anionic ligand does not take into account the covalent character of the bond between metals and ligand. Anionic ligand does not take into account the covalent characters of bonding between metals and ligand. Crystal field theory successfully explains the property of formation, color, structures and the magnetic property. In crystal field theory, ligand is considered as a point charge. As a result, anionic ligands iodine, fluorine, chlorine should exert the greatest splitting effect. The anionic ligand actually are found at the lowest end. The lowest end means it should be the left side of the spectrochemical series. The covalent bonds means the sharing of electrons, ligands and metals and ligands is found between the metals and ligands. And sharing of electrons means the sharing of electrons is possible when there is unpaired electron. Analytic ligands are some of the weakness of CFT, which are explained by ligand field theory and molecular orbital theory. Analytic ligands are some of the weakness of CFT and which can be explained by ligand field theory and molecular orbital theory. Bonding in metal. Bonding means double bond. Metal can be the transition metals. Carbonyl means carbon and oxygen. Homoleptic complex. What is homoleptic complex? In a coordination compounds, when there is one type of ligand, that is known as homoleptic complex, and it is in heteroleptic complex when there is different type of ligands, that is known as heteroleptic complex. The strong field ligands are carbonyl compound, NO, NH3. Weak field ligands are all halogens and water. When the ligand number is 4, it will be tetrahedral complex. When the ligand number is 6, it shape will be the octahedral. Homoleptic carbonyl compounds. Only carbonyl compound ligands is connected with it, and homoleptic carbonyl compounds are formed by most of the transition metals. Then carbonyl compounds have simple and well defined structure. Only one type of carbonyl ligands are present. So only carbonyl compound is connected with the homoleptic carbonyl compounds. Only carbonyl ligand. Only carbonyl ligand can be found by homoleptic carbonyl compounds are formed by most of the transition metals. So most of the transition metals form the homoleptic compounds. The carbonyl compounds have very simple as well as defined structure. The carbonyl compounds have very simple as well as defined structure. The carbonyl compounds have very simple as well as defined structure. Only one type of carbonyl ligand is present, and CO is the strong field ligand. CO is the strong field ligand. So homoleptic carbonyl compounds, for homoleptic carbonyl compounds, the tetracarbonyl nickel, and that is NiCO4, X equal to 0, and its shape will be tetrahedral. And pentacarbonyl iron, and its shape will be the trigonal bipyramidal. Hexacarbonyl chromium, its shape will be the octahedral. And decacarbonyl dimanganese, its shape will be two pyramidal, and unit joined by manganese bond. There is no bridge bond. So in CO2 CO8 there is two bridge bond, and it's formed by CO bond bridge. Two cobalt metal, here bridge bond is present, and number of bridge bond is 2 here. CO2 CO8. Wait for a minute, I'm just coming. Please like and subscribe my channel. Please like this live and subscribe my channel. Please like this live and give a like and subscribe this channel. I need your support, guys. Now, what is a conductor? Conductors have a large number of free electrons. Allow free electrons, that means allow flow of charge. Free electrons resides inside the volume of the conductor. That means if free electrons resides inside the conductor. The free electrons means number of protons and number of neutrons equal to 0. Conductors have free electrons and that is situated inside the conductors. Conductors has low resistance. In conductors, flow of current is maximum. As we know, V equal to IR and I equal to V by R. So when there is low resistance, obviously there will be flow of current will be maximum. Conductor has high thermal conductivity. Conductor has high thermal conductivity. Conductor has low resistance, current flow maximum. So what is conductor? Means that I am telling about the information about the conductor. So conductors have large number of free electrons and allow electrons to move freely. That means allow flow of charge, and charge will flow in maximum amount and this resistance will be low. Conductors have free electrons and free electrons are situated inside the conductor. Electrons move freely within the conductors. An electron has positive temperature coefficient. Example: copper, silver, aluminium, gold and steel. What is the definition of conductor? A conductor or electrical conductor is a substance or materials that allow electricity to flow through it. A conductor or electrical conductor is a substance or material that allow electricity to flow through it. So consider there is a conductor and the conductor is connected with a battery and the battery has positive and negative charge. So from which direction the electrons will flow? The electrons will flow from negative to positive. As electrons are free and proton is bonded with the heavy nuclear force, that's why electrons will move from the positive to negative. And a positive charge or electron, so when there is flow of electrons, obviously there will be flow of charge, right? And when there will be flow of charge, obviously there will be flow of current. Atom has fundamental particles. So what are the fundamental particles of atom? The fundamental particles of atoms are proton, electrons and neutrons. Now what is free electrons? Free electrons means the neutral body. Free electrons means positive, negative. Free electrons means number of proton equal to number of neutron. Free electron means Q equal to 0. Here free electrons reside inside the conductor. Free electrons reside inside the conductor. Free electrons resides inside the conductors. Free electrons move actually move around. Electrons, free electrons allow to move freely. There is no bond between free electrons. So there is no strong bond between the free electrons. Please like and subscribe my channel. Hare Krishna, Hare Krishna, Krishna Krishna, Hare Hare, Hare Rama, Hare Rama. So what is free electrons? Free electron means the neutral body. So free electrons, there will be positive and negative. Free electron means number of protons and number of electrons is same. Free electron means charge equal to 0. Free electrons reside inside the conductor. Free electrons move all around. There is no bond between free electrons. Electrons move freely within the conductors. Electrons are free electrons. Electrons have low resistance and current flow will, so when there will be low resistance and current flow will be maximum. It have a large number of free electrons and allow free electrons. I mean free electrons are reside inside the volume of the conductors. The source of charge is electron. Charge can either be gained or be destroyed. Its quantity is equal to A. So let us revise from first. What happened? Sorry for the interruption. Now in physics we have read about, we are dealing with the first chapter of class 12 of physics. So class 12 physics first chapter deals with the property of charge, nature of charge, then electrons, electrostatic force. So properties, I would say property. So what is property? Property means characters, and when there is a property there should be an effect, and mass is a property and mass will lead to effect. Mass is a property and obviously mass will lead to effect, and its effect will be gravitational force, moment of inertia. Charge is also a property. Charge is a physical property, it's not a chemical property. So charge is not visible, that's why it's a physical property. And charge is also a property, and when there will be no property there will be no effect. How a body can be charged? A body can be charged by giving some electrons and taking out some electrons, and electrons can only be transferred because electron has no strong bond, and proton has strong bond with the nucleus, that is the strong nuclear force, and due to strong nuclear force there is a strong bond. Due to strong bond, protons cannot be moved, protons cannot be given on taking and taken out from any body. If we want to take out protons then we need high energies, and that's why it's not possible. So protons are connected with neutrons with a strong heavy nuclear force. That's why proton cannot be taken out from any body, and electron is not bonded with any strong bond. It is situated outside the orbitals, and it can be easily transferred to any body, means it can be given to any body and it can be taken out to anybody. When an electron is given to any body, any body, that means there will be excess of electrons in that body, and excess of electrons indicates the negative charge, and when there will be excess of electrons their mass number will be increased, and when an electron is taken out means there will be deficiency of electrons, and when there will be deficiency of electrons their mass will decrease. There are three states of charge. First one is the rest of charge. Second one is the charge moving with constant velocity, that means charge is moving slowly. And third one is the accelerated manner of charge, that means the charge is moving in a faster manner, and all these states will give effects. When the charge is at rest, its effects will be the electric field. When the charge is moving with constant velocity, its effects will be the electric field and magnetic field. When the charge is moving in accelerated manner, its effect will be electric field, magnetic field and EM wave. Some important points of charge. Charge is donated by Q, and it's a scalar quantity. It is additive in nature. It is conserved. That means charge can neither be created nor be destroyed, and it can be transferable. The total number of charge are present, it means that the total charge on that isolated system is conserved. Charge is not visible, that's why it's a physical property. Charge is quantized, that means it is available in the market. For example, it's my own time I am using. For example, if we want a pen, we are not saying that we want half pen, we are saying we want 1 pen or 10 pens, so it is in integer. So charge is quantized, it should be in integer. The formula will be Q equal to N. Q means charge of any body, and N means the integer number, and E means the charge of electron. Charge of 1 electron is minus 1.6 into 10 to the power minus 19 coulomb. The unit is very important. So we should never forget that the charge of an electron is minus 1.6 into 10 to the power minus 19 coulomb. It can be written as minus E and its sign is negative. Charge of a proton is plus E, that is plus 1.6 into 10 to the power minus 19 coulomb. Charge of a positron, charge of a deuteron and charge of a proton, they are same, and that is plus 1.6 into 10 to the power minus 19 coulomb, and its sign is positive. Charge of a neutron is 0. Neutron, that indicates a neutral body, and number of protons and number of electrons are same for neutral body. The SI unit of charge is coulomb. The CGS unit of charge is ESU. ESU is the smallest unit of charge, that is known as Franklin. The largest unit of charge is Faraday. It's not Farad. Farad is the unit of capacitor, and this mistake I have done in my tuition test. So SI unit of force, though we will read electrostatic force, so we have to know the force of unit of force. The SI unit of force is Newton, and the CGS unit of force is Dyne. 1 Newton equal to 10 to the power 5 Dyne. 1 coulomb equal to 1 by 10 EMU. 1 coulomb equal to 3 into 10 to the power 9 ESU. 1 ESU equal to 1 by 3 into 10 to the power minus 9. 1 by 3 into 10 to the power minus 9 coulomb. 1 ESU equal to 1 by 3 into 10 to the power minus 9 coulomb. 1 Newton equal to 10 to the power 5 Dyne. And up to this, I think. Yes. Why we get shock? We get shock due to discharge of electric charge through our body, which are accumulated on rubbing with the insulating surface. When we open a door of a car, we get electric shock. When you are holding the iron bar of a bus after sliding from our seat, okay, when we are holding the rod of an iron bar after sliding from our seat, so we will get electric shock. What is static? Anything which is at rest and that doesn't move with time, that is known as static. So we will read about the electrostatic force. Static, electrostatic deals with study of force, study of field and study of potential. Electrostatic arising from the charge. The source of charge is electron. And what is conductor? Conductor should have free electrons. Conductors have low resistance. It should have high thermal energy, high thermal conductivity. Conductors has a low resistance, and when there will be low resistance, current will flow maximum. Free electrons resides inside the conductor. Electrons are allowed to move freely in the conductors. They have positive temperature coefficient. Example: copper, silver, aluminum, gold, steel. What is conductor? A conductor or electrical conductor is a substance or material that allow electricity to flow through it. A conductor or a electrical conductor is a substance. A conductor or a electrical conductor is a substance or material. A conductor or a electrical conductor is a substance or materials that allow flow or that allow electricity to flow. Conductors or a electrical conductor. A conductor or a electrical conductor is a substance that allow electricity to flow. Electron flow from from negative to positive. Negative indicates that there will be flow of electrons, and when there is flow of electrons, there will be flow of charge, and the charge will lead to the current. Free electron means neutral body, that means positive, negative. Free electron means number of protons equal to number of electrons. Free electron means the net charge will be 0, and conductor surface. Free electrons can move freely, and free electrons have positive temperature coefficient. Its resistance is very low. As we know, V equal to IR, so I equal to V by R. So I is inversely proportional to R. So when there is low resistance, the current will flow higher. There is no bond between the electron. What is conductor? Conductor means charge of an conductor. means charge of a conductor is 0. If given some electron that is negative charge, suppose the result will be, if given some charge that is negative charge, okay, and there will be excess of charge the stored on the surface, means excess charge is stored on the surface of the conductor. Consider a conductor, and then the conductor charge is neutral, and we have given some excess charge, and when we give some excess charge, it can be proton and it can be electron, both. The excess charge will situated on the surface. So conductor is inner and surface. So excess charge, that is positive and negative, and it's stored outside the conductor. If some excess charge is given that is positive and negative to a conductor, it will reside on the surface. So if an excess charge is given to a conductor, it will reside on the surface. So up to this I have completed my revision. So thank you.